Oh, oh, this thing's always been on. Huh. Anyway, welcome to episode 2 of Not That It Matters. And the thing that I was thinking about was before the internet, how I used to kill time or, I don't know, savor time. So today we're going to be talking about sets. Anyway, thinking about how I used to kill time when I had to read books. One of the favorite books I had was, the Guinness Book of World Records. I mean, just because like every year there was an update. So maybe there's a bigger building, or that guy with the really long fingernails had even longer fingernails, or there was some guy who took the most vaccines. I don't know, things like that. Anyway, one of the ones I remember for some reason was that there is a word out there that has the most synonyms in the English language, and it turns out to be set, which is really unassuming. But it turns out there's 430 synonyms for set, which is kind of like the number of uses for the peanut that George Washington Carver came up with, who, besides being the guy who chopped up George Washington, also developed a lot of uses for sweet potatoes and peanuts. I forget what they are besides sweet potato fries and peanut butter, but I know there are a lot of them. Anyway, one of the synonyms for set that is kind of interesting to me is this idea of set theory. So you've probably seen these little Venn diagrams before, and this is a way of visualizing sets. So the idea is like you have this, oh, here's all the things that are A, but some of the things that have in category A also have to be shared with category C and category B. And check this out. There's even this overlap between all three. All right, this is really interesting. Anyway, you've probably seen these in grade school, and maybe you thought like, if there's got to be a way to show how often do I use Venn diagrams versus how often do I use bar charts, and maybe there's a scatter plot we can make of the two. This is probably also why you hated math. So you've probably wondered, or maybe you haven't wondered, what do you actually do with sets? So one answer is you can make counting really complicated. So here's an example of how you can use sets to count. So for example, look at this. This is 0. So 0, or this is the null set, just represents nothing. It's a category where there's nothing in it. So anyway, just think about that. So think about nothing. And now we're going to move on to 1. So 1 is the set that contains 0, which means it's the set that contains the empty set. So check that out. We just counted from 0 to 1. Now, if we wanted to go to 2, oh, look at that. All right, it's the set that contains 0 and 1, which means it's the set that contains the empty set and the set that contains the empty set. Anyway, you can kind of see where this starts to go on, but you can count all the way up to infinity. Don't do it now, using sets. So what? Well, it turns out that early in the 20th century, there's this whole rush to try to create a unified theory of mathematics, like from the ground up, from those basic things, kind of like what we were just talking about here with counting. Can we make a fundamental unified theory that describes all math? And one of the mathematicians that was involved with this worked with sets, Kurt Gödel, and had this idea of looking at sets. So instead of just using them to count, which is really interesting, what he had is this idea of to try to translate using what are called, well, I mean, I'm sure he called them something else, but they're called Gödel numbers. And the idea is that you can just assign a unique number to every mathematical symbol used in mathematical proofs. So like, by the way, there's like way more of them than this. This is like the first 6, but the idea is like, oh, we have a mathematical symbol that just means not. We'll just assign number 1 to it. Number 2 is a symbol for or, and so on. And so the idea is that you can translate equations and proofs into numbers. And so then you can start talking about, well, okay, these numbers are shared with these numbers. And so you can actually start to talk about reducing all of mathematical proofs basically to arithmetic through some really interesting, but like way more detailed stuff that I'm going to go into here. But the idea is like you can actually translate all mathematical proofs to just numbers and seeing like, hey, does this intersect with this? And this was part of this whole effort to try to show, okay, like, is there a way we can make a complete theory of mathematics? And using this formulation, you can actually start to look at a general structure of math, and you find out the following, which is If you try to make a complete theory of math, that is, if you have a set that contains all the mathematical representations that correspond to all the equations that one proves the other, which proves the other, you will eventually end up with a paradox. You'll eventually end up with a contradiction. So like examples, like, the set that doesn't contain itself. So that's not even like the empty set. It's sort of well, anyway, you can't resolve it. That's a paradox. So this is like where in Star Trek, if you told a computer this, it would like fry out, like, hooray for Captain Kirk. All right. Anyway, so the idea is that if you try to go for a complete theory, bam, paradoxes. But if you try to avoid paradoxes, that means you're constantly then always having to add more statements and more proofs to try to describe everything else that's in the set. So if you have what you think is a complete set, well, in order to avoid a paradox, you have to add additional statements to deal with all the other cases, which means that if you avoid paradoxes, it'll always be incomplete, which basically means you can't make a complete theory of math. You always eventually have to make assumptions. So anyway, if you ever hated math, maybe this is why. You basically can never be consistent and complete at the same time. Oh well. Thanks, Venn diagrams. So let's go on from math and sets to gods and sets. So we're going to talk today about the Egyptian god Set. So the Egyptian pantheon represents, well, these are sort of like in Egyptian mythology, they ascribed all the natural forces of the world, they gave them personas. And these are some of the representations here. And this is like, I don't know. Anyway, Book of the Dead, blah, 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 blah. They built some pyramids. All right. Anyway, we're going to talk about two of these gods, one of which, oh, look at that. It's another Set. Set turns out to be the god of desert, storms, disorder, violence, foreigners. I don't know. Anyway, this is just sort of a grab bag. Somebody made this up at the time, and now it's chiseled in stone. Okay, so that's the Egyptian god Set, this jackal-headed fellow here. And then Horus, I guess, is only the god of kingship and sky. So, well, whatever. Some sort of bird. Oh, yeah, falcon. Anyway. All right. So these are the two gods we have. And there's all this mythology about it because, like, of course there is, because if we already made up characters, we have to make up a cinematic universe, right? Okay. So it turns out, there's a lot of rivalry between these two gods. They're fighting over who gets to be the king of the gods. Of course, you're probably wondering if, like, gods are omnipotent. Why would there be something even more omnipotent than that? I don't know. I guess it's the set that contains sets. So anyway, rivalry. We want to see who's the god of the gods, king of the gods. Anyway, but what we have is like one of these instances in Egyptian mythology. So in a key episode in the conflict between the two, Set sexually abuses Horus. Now that's actually in the mythology. All right. So Set's violation is partly meant to degrade his rival, but also involves homosexual desire. In keeping with one of Set's major characteristics, his forceful, potent, and indiscriminate sexuality. In the earliest account of this episode, in a fragmentary Middle Kingdom papyrus, the sexual encounter begins when Set asks to have sex with Horus, who agrees on the condition that Set will give Horus some of his strength. The encounter puts Horus in danger because in Egyptian tradition, semen is a potent and dangerous substance akin to poison. According to some texts, Set's semen enters Horus' body and makes him ill. But in contending, Horus thwarts Set by catching Set's semen in his hands. Isis retaliates. Isis is another god, by the way, retaliates by putting Horus' semen on lettuce leaves that Set eats. Set's defeat becomes apparent when this semen appears on his forehead as a golden disc. He has been impregnated with his rival's seed, and a result gives birth to the disc. In contendings, which is one of these fragmentary papyri, Thoth, which is another god, takes the disc and places it on his own head. In earlier accounts, it is Thoth who is produced by this anomalous birth. So now we have another god. There are a lot of gods. I wonder if there's a way to count them all. Anyway, if you have any questions, stuff they want me to talk about, just ask. Here's the email address at notthatitmattersshow gmail.com. Anyway, I hope you have a good day. And just remember, be the content you want to see in this world. Thanks.